I need to introduce who is Qualcomm. Uh, Qualcomm founded 40 years ago by Dr. Irvin Jacob, who at the time told one day everyone will have their own phones. So it has happened 20 years ago, right? So Qualcomm is the company developed the communication technology, CDMA, we call it. These days it's called 2G, second generation of technology. Later on, we developed 3G, 4G, 5G. Now it's working on the 6G technology. The technology has been used globally and benefit everyone, I think, including everyone in the room, right? Beyond the modem technology, we also developed a chipset for many industry, uh, uh, including the smartphone, uh, AI PC, and also XR devices, including AI glasses, AR glasses, and automobile. And also later on, we get into the business of data center. Um, to enable those solutions, beyond the telecommunication, we need multimedia uh, to be available for the manufacturer to enable those features. Multimedia, including the automatic speech recognition, vocoder, display technology, camera, and video, right? Related to CVPR is the computer vision technology. Today, we are going to spend more time here. In Qualcomm, the computer vision technology started from 15 years ago. We have people actually 10 years ago with the team in the room. We also have a lot of people is with the team here today, right? So, Charming, if you have any opinion want to share in this workshop. So let's look at the computer vision. The technology starting from 2011, we have actually enabled certain features in Qualcomm's Snapdragon platform. At the time, it's most likely is you do feature extraction and pattern recognition, put things together, it gets something done. But later on, after the booming of AI technology, we move on to neural network-based solution. And later on, to enable multiple solutions on edge, we need foundation models. We need shared backbones to solve the problem together, right? These days, the agentic visual intelligence is the focus, not only getting a perception result from your camera, but also we need the device to make to understand, to reasoning the situation you are dealing with, to make plan, to take actions, right? Such as the use case in robotics. So let's look at the first milestone on the edge. We know deep learning is starting from combining of feature extraction with pattern recognition together. It always starts from an image, right? If we do a really useful application in phone, normally it will require several features to be enabled together. We cannot go back to the image again and again, which will be too slow and also burn extra powers. So the shared backbone is the first technology we have enabled. So in this example, we designed UNet with encoder and decoder with transformer, so that different features like segmentation, depth, or object tracking can be addressed by different attention headers, so that with a shared encoder, shared backbone, the feature extraction can be done together. So that's the first technology we applied in the phone. I think it started from 8 years ago, right? Now it's used in many phones people are using. The second transition is from visual perception to visual intelligence. Uh, so, you know, the first step in the computer vision, we detect object, recognize object, that's it, right? You are not making any intelligent call after. With the enabling of large language model, vision language model, uh, the device has started to be intelligent to make a call, make a decision, make a recommendation to the user, right? Like the AI glasses use case. You can talk to the glass with questions, with things you want the device to help you to solve. That's is happening today, right? Um, the large language model start from the cloud. It is still in cloud till today, right? One of the effort from Qualcomm, including a few other companies, is trying to move the solution from cloud to the edge. There are several motivations about doing so, right? The latency is the first one. If you always wait for the network, upload, download the answer for you, uh, although it's a technology Qualcomm is working on, develop the solution, but in certain case, the latency is still too long, not short enough. And also the bandwidth. Think about if you have millions of surveillance camera streaming raw video together, it's a huge load to the system, right? So edge-based intelligence is necessary. Also, privacy, reliability, and also the cost is other factors, right? Like the cost these days. If you use the cloud code uh, daily on the cloud, right? Uh, you really burn a lot of tokens, which equivalent to the money. Uh, you know, at the time, people may not care that much, but I think over a few months, we will realize how much money we have burned there. So that will be a factor too. If you have a local solution, which may reduce cost by 10x easily. So that's why we are really focusing on moving the cloud-based solution first to hybrid solution, then to the edge-only solution. In Qualcomm's platform, we call it Snapdragon. We have Hexagon NPU enabled, focusing on solving the dense network problem to make it low power and real time. We also have Adreno GPU available for the display first, for the game second, and for the AI third, I think. That's the order till today. If running some solutions popular these days, for example, the mixture of expert GPU is more friendly. We have shown some result, very positive in the GPU, Snapdragon GPU. Also, we have a Orion CPU available, which is actually working with NPU, GPU together to build a heterogeneous computing environment so that make the solution very flexible. Give it a try when you have a chance. So by saying all those, we need to have an ecosystem, right, to support the customer, OEM and third-party developers. This ecosystem in Qualcomm we call the AI Hub. In AI Hub, we have hundreds of popular neural network models enabled there. And also, we have a 30 plus large language model, vision language model enabled. I think that the biggest model enabled there is in NPU is 7 billion model, in GPU is 35 billion model. So, which is quite large already compared with what is used practically in the cloud. So here is an example of how easy to enable your own solutions in the AI Hub. You can upload your solution there, and we have a series of tools to help you to quantize the model, to test the model, and to upload the model for others to use. Now let's look at what is happening today and also in near future. Uh, from visual intelligence, we are seeing the trends to go to agentic visual intelligence. Why do we need to do so, right? Agentic visual intelligence actually provide the possibility, right, to expand the expertise of engineering to sevenfold, so that those technology expertise can be duplicated, can be uh, transferred from one project to another, right? So we are actually looking at it from in three stages of such kind of development. The first stage is to build the platform as an agent native platform, so that the solution we introduce is agent friendly. Let's take a close look of the solution. In the agent native platform, we have introduced a lot of dedicated agents like model agent, data agent, evaluation agent, documentation agent, etc. So one orchestrator can coordinate all those efforts in the process. I will show the example later. So by using such kind of design, right, we actually transitioned from engineering using AI to AI agents doing engineering work automatically. Uh, so no matter we like or not, it's the trend, right? We need to go there to give a try to see, if the result is better than what we have today, and you know, uh, yeah, last week I was in a UCSD workshop with a lot of students and professors. Uh, I heard the concern from students, including professor. Uh, when you have so many agents doing things, where the student will go after graduation. Uh, so that's a different story we can discuss in different place. But no matter you like or what, it's the trends, right? Uh, I think in this loop, the human is still at the position to judge what is right, what is wrong at the end of the day, so that to have the student ready to use the tool AI agent as your partner, your best partner, is the way to go. Yeah, that's my recommendation to the student. So in this example, we are actually introducing a framework called Qualcomm Accessible Computer Vision Library. So in this framework, the agent is a native platform. You can see the agent is here, right? With the orchestrator, there are many parts of sub-agent here to handle the infrastructure, handle the hardware acceleration, and also handle the pipeline generation. Um, you know, before having the agent, right? We can introduce the model zoo with the AI Hub. Now, with agent, the application pipeline can be generated semi-automatically today but could be fully automatic in the future. So the second point I want to make is, uh, uh, which is what is happening today. Build your production by agent. So in this example, actually, we have a product to introduce a unified framework for event detection, not object detection, event detection. Like people, how many people get into the room, if there's any accident happen, such as, right, you can define the event, then the system of the agent will help to build the pipeline. Here's two examples. The first, the task is find a abandoned object. You can see that the people used to sit here associated with a backpack. When he left, the backpack left over there. So the agent system can use the unified pipeline to design the application automatically. The second example is a missing object. So there is a backpack uh, on the chair here, right? Then someone came in the scene and pick it up. Then we know something is missing there. So such kind of application, right? We used to do it fully manually, case by case, to address the customer's requirement. These days, we build a unified framework so that customer can define their own task, and the agent can create the pipeline automatically. So the last one is the build of agent, we call it. Let's take a look of the example. This is the system we designed for forensic search. We know a lot of civilian system, right? Recording 24 hours, 7 days a week, a lot of videos. Nobody actually look at them. How to solve those problems? That's the goal for this system. We call it the 4C. In this system, we have a lot of cameras built up, right? With video index inside. Means when video is recorded, the scene has been converted from pixels to tokens, or you can call it high dimensional vectors, so that the people can system can sort the information from it, right? So after such kind of a real-time process, we build the searchable video database. So once there is a query from user, right, such as when did this person, the person is indicated by a picture. It could be by text too, with what kind of appearance enter the room, right? That's the question. Then we have an agent, multimodal large language model agent. The agent will interpret the question and into action to search the searchable video database to come up with a result. This person entered the room at certain time and left at what time, right? So such kind of system is running today in Qualcomm the Cloud AI 100. So it is between a big server, cloud server, and the edge solution. We call the edge server. So for company, for building, for some small scale of use case, right? Such kind of server can keep all your information locally and process them according to the query from the user. So here is the video example. It will help you to understand what is happening today. So the question now here is, did you see four or more people gathering together? So the system start to search, find the two pieces of videos. First is with 4 people, second is with 6 people there. And then the question is, did anyone fall on the ground? Uh, were they helped by someone? So is Matt in the scene here? So the guy was so happy someone for finally for down on the ground. Uh, so that's actually made up a thing, right? When we want to test the system. So the system found those things. Here the question is there anyone with a pink umbrella and who appears after, even without the umbrella? So we found the people with the umbrella and also found her when she dropped the umbrella after, right, in another scene. So the last example is to find the bag, anyone with the bag like this. So the query can be in the image, can be in the sketch, can be in text, the combination. So that's the example. Now let's take a quick look of what we are showing in the demo booth starting from Friday. Yeah, starting from Friday. The first demo is the same of the forensic search. I won't repeat. It's the same. You can see it live demo there. And the second is running in the Qualcomm's enabled AI PC. From this view, you can see a lot of information has been attracted live, including the body skeleton, facial landmark, gaze, hand gesture, etc. Oh, we can put in a lot of things. This is an example of a shared backbone, right? We have solutions very efficient on the edge. The third demo is the virtual try-on, we call, which is actually taking a picture and we change the clothes virtually so that you don't have to do it in the fitting room anymore. Let me see. Yeah, it's stuck. You see, that's the input image, and this is the virtual dress. The image, everything is done on device in 2 seconds, within 2 seconds. It's kind of a application of a diffusion model, right? The next is AR agent. In this system, we build all these solutions together in the AR glasses with a companion device. Companion device could be your phone, could be something else. It depends on the design from manufacturer. So what we can see here is there is a Gaussian spreading based avatar. The team is here developing the solution, uh, talking to you based on a large language model with automatic speech recognition, with TTS, with real-time audio to brain shape, lip syncing, and facial expression. And later on, they add gaze control too, so that such kind of system is running on the edge real time. You will see this demo live too. And the last one is on the wearable watch. If you have a camera in your watch, right, we can do face recognition to unlock the watch, and also the solution can provide recognition of gesture, recognition of facial expression to convert them to emoji. So you can use automatic speech recognition to dictate your reply in short message, for example. Then add a happy face after to add a happy face emoji, right? Or use a thumb up to answer some short questions, right? You see the face there, emoji face, which will be added into the your reply automatically. So the chip used in the watch we call the wearable application, right, which requires a low power, low power solution, and But low power doesn't mean low latency. We need to get the result immediately. You see the result is very short. The latency is very short there, right? So the last, I think we wanted to introduce what Qualcomm University Relationship Program has done in the past many years. So far, we have 100 plus of annual research engagement with different universities, labs. We have worked with different conference to support them at a certain level of strength. And also we have working with a lot of universities. So we actually have different program for different customers, if we can call them customers, right? For students, we have a program called QIF, Qualcomm Innovation Fellowship. Yeah. So student can submit your proposal to compete there. We give the fund to the student group. We are also working with professors directly. Sometimes we work with university in the labs at that level too, such as in UCSD, we have the many programs there. At the university level, there is a collaboration too with Qualcomm. The last, I want to maybe 1 minute to talk about low power computer vision challenge, right? This is the second year we have collaborated with Professor Yongxiang Lu from Purdue University. So this year, the price has been raised significantly. So the first prize is 6K, second 3K, etc. I think, in this competition, what, let's say, to tell the truth, what we have be benefited in, right? We introduced Qualcomm's platform, Qualcomm's AI hub ecosystem to more students and professors, including sometimes startup companies, right? So that let people know what is available today so that they can pick up things quickly, easily, right? And where to find the solution, where to find support. So I think it's very good. The result after my talk, people will announce the winners and what else? Also give the certificate. Certificate, okay. Yeah, HOV certificate. Thank you very much. Yeah, that's